Which compound contains only 8 covalent bonds? So the best way to do this is just to draw the structure. So if we take a closer look at A, it's trying to highlight that it has 2 hydrogens like that, one O, which already has a H bond with it, and it's the same thing below, right? So it's the same thing again. So maybe I'll skip it. I won't draw. Okay, fine, I'll draw it. I'll draw it. O. And one source of confusion is that normally we put the OH together because it, looks nicer that way. But I'm making it separate so we don't miss out that bond. So we're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 bonds. We're looking at 8 covalent bonds only. Alright, I have a strong feeling this is our answer because it's very similar to this, but it doesn't have the OH bond, right? So if I draw this out, let me just be a bit lazy and yeah, let's do that over here, right? So 1, 2, 3, 4, 5, 6, 7, 8. So pretty confident now that the answer is indeed B. Wow. Right? Okay. What are the correct anode and cathode products when aqueous copper sulfate is electrolyzed using copper electrodes? So this is very similar. They're not saying it. This is very similar to the setup we have for purification of copper, right? And what's going to happen at the positive electrode is copper will lose electrons because it's positive, right? It's going to take away electrons. So at the anode, electrons will move away from it. So copper metal can only lose electrons over here forming, and so it's losing electrons, right? So what is this going to look like? It's going to look like the metal, I did something wrong here. Yeah, the metal will dissolve, right? The metal solid will start turning into aqueous ions. Then at the cathode, what's going to happen is it's going to gain charge. The copper metal can gain charge. It's going to be the copper ion in the solution which gains charge and turns into copper, right? So what's that going to look like is the solution, well, you don't see it, but the mass of the copper over here will increase. So you'll see larger copper, like a big mass of copper forming over here, and over here this will deplete. Let's see what they're saying. Products when aqueous, so the product is aqueous copper ions at the anode, that's true, and copper metal at the cathode, that's true as well. So A is our answer, right? Highlighting A is our answer, right? Let's take a look at, well, you won't have oxygen gas or anything else, so the other options aren't really, yeah, so we kind of worked it out. So it's very reminiscent of the extraction of copper electrolysis. In the graph, curve 1 was obtained by observing the decomposition of 100 centimeter cube of 1 mole per decimeter cube of hydrogen peroxide. Okay. Catalyzed by manganese, what is this, 4 oxide, right? That's 4. Which alteration to the original experimental conditions would produce curve 2. And notice curve 2. It's not as steep, so I'm guessing they're removing the catalyst or somehow slowing the rate of reaction. The other thing is that it's also producing more oxygen. Do you guys see that? More O2 is produced compared to A. So over here, less O2 is being produced. Less gas is being produced. How do you get that? If you have more hydrogen peroxide, you can do that. So how much peroxide do we have right now? We have 100 centimeter cube of 1 mole per decimeter cube. Put it in the formula and you'll get, you currently have 0.1 mole of hydrogen peroxide, right? So we want more than that and slightly more. Which alteration, okay. adding 0.1 mole per decimeter cube hydrogen peroxide into the solution. Now currently the concentration is 1 mole per decimeter cube, right? That's, you have 100 centimeter cube of 1 mole per decimeter cube. You're adding it, so your graph will become higher, so that's true. But will it become less steep? Think about it. Think about it. Think about it. Think about it. You're adding some really dilute amount of hydrogen peroxide. You have 1 mole currently in the reaction. The first time it takes place, this graph has a concentration of 1 mole per decimeter cube because you're using that. In that, if you add 0.1 mole, which is way dilute, 1/10 of the concentration than this, would it also slow down the curve, right? Think about it this way. I think it's going to be confusing for most people. So here's some, I go to my usual beverage of choice, which is Pepsi. I'm actually against soft drinks. I don't even drink them, but right? Now, in another glass, let's say I have diluted Pepsi. So it's like 50% water, 50% Pepsi, right? So 50-50. Let's call that solution 50%, right? So it's less sweet, right? Now, if I take this solution and add it over here, is it true I am adding more sugar to this, right? That's completely true. But I'm also making it less sweet, and that's kind of counterintuitive, right? I add something with more sugar into this, but I'm also making it, the whatever its new height is going to be, it's going to become less and less sweet. How's that possible? Well, over here, once you add sugar, you're adding a lot more water for every sugar you're adding, right? And that's what's going on here, right? Sorry, that's what's going on here. You're adding more peroxide, so there's more oxygen being produced because essentially there's more hydrogen peroxide. But the rate is also slowing down because the concentration is decreasing, because there's more calories over here of sugar at the end when you mix these two together, but still the Pepsi is less sweet because you also have a lot of water, right? I hope that makes sense, and the best answer over here is A, and that's our answer. Let's go over the other choices real quick. Lowering the temperature will make the graph this, but it won't change the height. So it would look something like this would be a more accurate B graph. It won't change the height where it's finishing off, right? Using less manganese oxide should give you something similar to this because it would slow down the rate, not produce more oxygen. Using a different catalyst, well, that would still not change the height. I don't know. Maybe if it's a really good catalyst, it might bring the graph on this side, or maybe somewhere on this side, we don't know. But yeah, let's move on. Which row correctly describes the oxides? Aluminum oxide is the poster child of amphoteric. Ampho, right? Now over here, you're talking about in the next one, yeah, it's potassium. Potassium is in group 1, so this has to be basic. This also has to be basic because it's group 2. Alkaline earth metals, alkaline metals. And sulfur dioxide is known to be very acidic, right? So what's the matching with our list? Amphoteric, basic, yeah, D is the best bet, right? Okay, let's be fancy about it. Let's give D its day, and let's move on. Aluminum reacts with chromium oxide because it is more well, let's just take a look. It's a displacement reaction. Aluminum looks at chromium, looks at that oxide, wants to displace chromium and be with that oxide, and it does so. So that makes aluminum the cooler kid in the block, or the more reactive one than chromium. This is more reactive, this is less reactive. And lo and behold, the first statement is aluminum is more reactive than chromium. That is true. That is true. A similar reaction would also take place between aluminum and iron oxide. Will it? Where is po, so, ka, mul, Zittle. Yeah, so aluminum is way before iron, so yes, it will. Indeed, so it will, very well so. Okay. Iron 3 oxide is reduced by another metal in the blast furnace. I don't know where this question shows up. Okay, iron oxide is not reduced by another metal. It is reduced by carbon. I like how every time I mess up my marker, I just go, I am very annoyed. Anyway, it's reduced by carbon. Wait a minute. Yeah, it is definitely reduced by carbon. I was thinking if they're trying to confuse the reduced part or oxidized part. But yeah, definitely carbon. Okay, 1 and 2 are correct, and our correct answer is B. Correct answer is B. The diagram shows how an underwater iron pipe can be protected from rusting. So this is iron and they've put a metal Z on it, and they're trying to refer to the sacrificial property of metals, which means that if a more reactive metal is attached, welded, right? I hope you guys know what welding is. Welded onto iron, especially you see this not on pipes, but like on the bottom of ships, right? And if metal Z is more reactive than iron, what's going to happen is metal Z will say, I'll protect iron, I'll sacrifice myself first. So the water will end up, or like the chemicals in the water will end up oxidizing this metal first, and once this is completely gone and no more, will the iron start rusting. So very interesting phenomena. And yeah, so this happens when metal Z is going to be magnesium. And between magnesium and copper, magnesium is more reactive than iron, and iron is more reactive than copper. Or in other words, copper is less reactive than iron. So copper won't do it. Because it is blank reactive, it is more reactive, like I just said. It's more reactive. So this is more reactive. So we got D is our answer. Which two gases do not damage limestone buildings? Well, limestone is primarily calcium carbonate. So this, if you want to read more about it, you'll find this in air and pollution chapter, that chapter. Calcium carbonate, what happens is with acid rain, the acidic property, well, acids will generally easily react with carbonates, turning it into calcium oxide and carbon dioxide. So what happens to buildings made out of limestone is over time, they'll start eroding because acid, right? So essentially what gases over here are not acidic? Now, I don't know how confident you are with this. Nitrogen is not acidic at all, because otherwise we'd be in for a very difficult time, because that's 80% of air, right? Carbon monoxide, contrary to popular belief in the O-level student population, carbon monoxide is also not acidic. It's really bad for you, but it's not acidic. What is acidic is carbon dioxide. Carbon dioxide, have you heard of carbonated drinks? They're kind of, spicy, right? They're a bit spicy because once carbon dioxide is dissolved in water, it makes it acidic, right? Okay, moving on. So let's just go through this real quick. Nitrogen dioxide turns into nitrogen trioxide eventually and mixes with water when it rains and will damage to form nitric acid, HNO3, which will destroy limestone buildings. Carbon monoxide, of course, we talked about it. Nitrogen dioxide again and carbon, these two both will do it. Sulfur dioxide will also do it as well, right? So nitrogen dioxide and sulfur dioxide are atmospheric pollutants. The source for these are combustion engines, and sulfur dioxide comes from fossil fuels, right? So they're your two main air pollutants that we discussed that cause acid rain in our syllabus. And one of the main harmful effects of acid rain is that they cause damage to limestone buildings. Moving on, the correct answer is A. The concentration of aqueous sodium carbonate can be found by reaction with hydrochloric acid, of course, of known concentration using an indicator methyl orange. So essentially titration, they're doing a titration reaction. Which items of equipment are needed? So you tell me. Burette, measuring cylinder, gas syringe. Gas syringe is not really needed because their gas syringe is to collect the carbon dioxide gas, but you don't need it because the indicator will tell you when it is. So you just wait for the color change, right? Burette, measuring cylinder, thermometer. You don't need a thermometer either, right? Burette, pipette, conical flask. That's a classic titration setup. I actually am not a fan of this question. What if a student could use a thermometer and magically find the, then what you gonna do, huh? Okay, you don't need a stopwatch either. So essentially they're trying to say, hey, here's a titration reaction. What instruments do we need? You don't need a gas syringe for titration. You don't need a thermometer, and you don't need a stopwatch. So essentially they're giving you clear signs of instruments you do not need for a titration reaction. So now you know that C is the correct answer. The table shows the results of two reactions of an aqueous solution of a salt. You have sodium hydroxide where white precipitate is formed, and dilute nitric acid aqueous silver and you follow it up with silver nitrate, a white precipitate is formed. So you have two sets of ions, calcium and zinc as your positive ions, and iodine and chloride as your negative ions. So the first one is actually testing the calcium and the zinc, right? So notice how it says excess, right? So when you add excess of NaOH, zinc essentially will first give you a white precipitate that will dissolve on further addition. Dissolves in excess, whereas calcium does not. So calcium ions just give you a white precipitate. White precipitate, right? And the other one is testing for nitric acid, is testing for, with silver ions, is testing for the iodine and the chloride ion. So iodine over here, sorry, chlorine over here gives you a white precipitate. But iodine, on the other hand, will give you a yellow precipitate. So what do you think it is? You're getting a positive test for the chlorine and a positive test for calcium because it doesn't dissolve in excess, right? So you have calcium chloride as your answer. The answer is A. Which metal has to be extracted from its ore by electrolysis? Now, the idea behind this is carbon. If a metal is more reactive than carbon, carbon cannot displace it. And if a metal is less reactive than carbon, such as, well, iron, right? Iron is indeed less reactive. So carbon can be used to displace it. So carbon is kind of in abundance in our planet, on our planet, and we love burning it. So iron, if you want some iron, you can extract it. But it'll only work for metals that are less reactive than carbon, because then that displacement reaction can take place, and the more reactive element can displace a less reactive element, or in this case, metal. So the only one over here is sodium, which is the second most reactive after potassium, right? In our reactivity series. Everyone else over here is way below carbon in the reactivity series. So the correct answer is B. This is a test. You notice how many reactivity series questions show up. So I think people just generally find that a lot more difficult, even more than organic. Which statements about the properties of four alkanes from methane to butane is not correct? These negative questions, these not questions, right? I think they confuse people a lot more. So understand, they confuse me. So understand what they're trying to say. Okay, the successive members of the series differ in the formula by CH2, and that's absolutely true. And let's just write the first few down. CH4, C2H6, C3H, what is it, 8, C4H10. And you notice each carbon is increasing by 1, whereas each hydrogen is increasing by 2. So the difference is indeed by CH2. They increase in boiling point? Yes, they do. They increase in viscosity? Yes, they do. They share the same empirical formula? Yes, they wait a minute. No, they do not, because the empirical formula for methane is indeed CH4. Now, the empirical formula is the simplest ratio. Over here, it's CH3, clearly not the same. This is C3H8, the empirical formula, and this is C2H5. They're practically, they're just not the same. So that's the correct answer. I think people got mostly this question wrong because they just forgot about the not that was being highlighted. So one more time, the correct answer is D. A molecule of sulfuric acid has a structural formula shown. How many electrons are involved in the forming of all the covalent bonds in the molecule? Well, 2 electrons take part in one covalent bond, right? That's the ratio. How many covalent bonds do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 covalent bonds. Does that mean we have 16 electrons? These are answer. The energy profile diagram for the reaction is shown. There's a reaction. Is it endothermic or exothermic? I'm gonna say this is lower to higher, so absorbed energy. So it's endothermic. This is a endothermic reaction, and you can see that enthalpy changes going to be a positive value, right? Okay, which statement is correct? The activation energy of the reaction is H3 minus H1. I've done this question twice in my life before. This is the third time I'm doing it. Last 2 times I got this wrong because I kept mixing up these numbers, right? So what is activation energy? This is activation. Oh, I was going to do it wrong. This is the activation energy, right? That's EA. And how would I calculate it? Well, it's going to be H3 minus H1. The activation energy of the reaction is H3 minus H1, right? And then delta H of the reaction, just to confirm, is going to be H2 minus H1. Do we have that? That's incorrect. That's ulta. And H1, and that's still wrong. So the correct answer is indeed. Well, not indeed, but A. Which occurs during the electrolysis of dilute sulfuric acid. Hydrogen and oxygen are formed in the ratio 2 volumes of oxygen to 1 volume of hydrogen. Actually, it's the other way around, where you produce 1 volume of oxygen and 2 volumes of hydrogen. Clever trick though. 1, it's actually flipped to 2. Right? That would have made it true. Hydrogen is formed at the positive electrode. Let's see if that's true. What happens is the hydrogen, to produce hydrogen, you need hydrogen ions, which need electrons to turn into H2, right? And this could only happen, gain of electrons from the element will only happen at the cathode because that has an abundance of electrons. So this is wrong as well. It won't happen here. Oxide ions are oxidized to oxygen. That would be great if it were true. It's actually the OH ions in the solution that turn into, very interesting equation, I hope everyone remembers it. It turns into 4 of these, turn into H2O, oxygen, and some electrons. I think 4 electrons, because you have 4 here. I remember the 4. If I try to balance it out, I'll put a 2 here, and I'll put a 2 here. And it looks balanced, right? This is how this reaction takes place. I'd advise everyone to know this reaction. It takes the mystery away from electrolysis if you know this. So this is wrong. The dilute sulfuric acid becomes more concentrated. Well, that's the only one left. And it does, because the sulfate ion remains, and essentially what's happening is this reaction takes place and this reaction takes place. So essentially, where are these two coming from? They're actually coming from your source for both of them are H2O, right? So essentially, when this electrolysis is taking place, the amount of water is decreasing, but the amount of sulfuric acid in the solution remains the same, so it's becoming more and more concentrated. And D is our correct answer. Which statement about graphite is not correct? Okay, does it burn and form carbon dioxide? Graphite is essentially carbon. So that's true. Essentially, that's the same carbon you burn, right? That is, it is a carbon compound. That's not true. It is carbon. It's not a compound of carbon. It is carbon. It is a giant molecular structure. That's true. It is used as a lubricant in high machinery because it's so slippery. This layers love sliding over on top of each other, and other lubricants which are liquid will evaporate or boil away in machineries where, like, heavy industrial machineries which get really hot. So it's a good lubricant choice there. So our correct answer is, well, B. It's not a because it's not correct, right? We had to pick the wrong answer. So B is our answer. A carbohydrate such as a starch can be represented as shown, and if you've ever looked at a starch molecule, you've actually seen, instead of these X's, you've seen O's, right? And they're just talking about that. What is this? It's just oxygen, right? Moving on. P is a polymer that has 6 carbon atoms in each of the monomers from which it was formed. Is not a polyester. Was formed using condensation polymerization. Okay, let's go over this one more time. 6 carbons. I think is not a polyester is the easiest one to identify. Hey, looky here. That's a polyester because that's an ester linkage. And any other polyesters? No, I don't see any. We have 2 amide linkages, so it's not a polyester. That's not a polyester. Okay, so A is out, B, C, and D. Okay, has 6 carbon atoms in each of the monomers. So let's highlight the monomers for this. This is my 1 monomer. This is my 1 monomer, is it? Okay, well, it's one of those polymers where there are 2 different monomers, right? In each of the monomers. So this monomer over here has 8 carbons actually. 6, 7, and 8. And over here this has 6. So this is out. This is not true. Okay, let's take a look at another one. Let's take a look at C. And yeah, that looks like, well, these are 6 carbons. And there are also 6 carbons over here, right? So that's true. So far C is winning. Was formed using condensation polymerization. Condensation polymerization happens. Water is produced. So that could be due to the ester linkage forming with an alcohol, right? This would make an ester linkage. Or the other condensation polymer is the amide one, right? So the addition polymerization happens between carbon with double bonds, right? There's nothing else produced, and actually you don't end up really seeing a distinct linkage that can identify the type of polymer. So D is an addition polymer, right? And we won't look into it in too much detail because, hey, like we don't need to. It's not a condensation polymer, it's an addition polymer. The C is matching with all our criteria, 3 criteria, which are listed on top. So the correct answer is C. Hydrogen and nitrogen react to form ammonia. Ho ho ho. Which statement is correct? Ammonia is made in industry by the contact, well, by the Haber's process, guys, by the Haber's process. Haber's, right? That's French for Haber. Ammonia is used in industry to make hydrogen and nitrogen. Well, it's the other way around. Hydrogen and nitrogen are used to make ammonia because that's really good for the soil. Or you make urea out of it, which is really good for the soil. And ammonia is a very important chemical. Hydrogen for the forward reaction is obtained from cracking oil. Absolutely, this is true. You produce a lot of hydrogen when you crack some oil. Weed killers are manufactured from ammonia. Actually, that ammonia would actually encourage stuff made from ammonia, encourages plant growth, not kill weed, right? So D is out. Weed is unwanted growth of plants which kind of mess up your garden and whatnot, so they call it weed. I don't know why, but they're not required. I think they're just ugly and attract bugs, and people would rather have flowers or fruits, fruit-giving plants in their gardens or in their farms. So it also takes away resources from the soil growing itself, rather than we'd rather have plants take all the resources that we want to grow, like flowers and fruits and vegetables, right? So weed, not a good thing. So you don't want to grow it, right? Okay, so C, that's our answer. What is the number of moles of hydrogen in 3.2 grams of methane? So how many moles are there in methane, right? So in methane, that's 3.2. The moles of CH4, 3.2 divided by 16. So that 32 over 16 is 2. This should be 0.2 moles, right? Now take a closer look over here. They're talking about how many moles of hydrogen atoms are there. So let's make up a fake equation. If one molecule of CH4 randomly decomposes to its constituent elements, it'll make 1 carbon atom and 4 hydrogen atoms. One molecule can turn into this 1 carbon atom and 4 hydrogen atoms. So the ratio is between methane to hydrogen is 1 to 4. So if you had 10, you'd make 40. And if you had 0.2 moles worth of it, you'd just make 0.8 moles over here. So the correct answer is D, right? This question isn't really in the syllabus anymore, but we'll do it anyway. A solution of sodium carbonate was added to tap water. A white precipitate is formed. Which ion is present in the tap water caused by precipitation? Now, why? The reason I'm doing this question is a lot of people would have picked chloride, and that would be true if you had also followed it up by adding silver nitrate, because it's the silver nitrate that produces the precipitate, and there's no silver over here, so this precipitate will not form. So chloride is absolutely wrong. Okay, let's ignore B. These two will form, will react with the solution and will have carbonates. Potassium carbonate is soluble, much like sodium carbonate in the question. It's soluble, so there's no such thing as a precipitate. But magnesium carbonate will give you a precipitate, and sulfate won't give you a precipitate, right? So the correct answer is B. Iron is obtained in the blast furnace from the ore hematite. Which reaction takes place in the blast furnace? Calcium carbonate is used to remove acidic impurities. That is true. They turn into the slag, right? Like calcium carbonate is essentially added for two reasons: to produce carbon dioxide, which helps with the reaction, and the other thing, like the reduction of iron. And calcium carbonate will also prevent, help remove impurities by reacting with them and making them heavy so you can separate them easily, right? Okay. Coke, that is essentially the answer. Let's go over the rest. Coke is reduced to carbon dioxide. That would be true, but it's not actually reduced, it's actually oxidized to carbon dioxide. Hematite is oxidized by carbon monoxide. Hematite is actually reduced, right? Hematite, by the add they mean Rn2, iron 3 oxide, is actually reduced. It's a reduction of iron. It's already oxidized, right? It's pre-oxidized. Rust, this is rust. It's already in its oxidized form. You want to reduce it. Hematite undergoes thermal decomposition. No. Heat is used to help accelerate the reaction, but it doesn't do it on its own, right? It's actually being reduced by the carbon and the carbon dioxide present. So this is also incorrect. The answer is A. All right, some reactions are shown, and they're talking about catalysts. So sulfur dioxide turning into sulfur trioxide is the contact, is part of the contact process, and the correct catalyst over here is vanadium 5 oxide. Number 2, that is reduction of an alkene to an alkane. Over here you use nickel as a catalyst. And over here, this is water. This is ethene reacting with water, turning into alcohol. So I believe you use phosphoric acid over here. H3PO4 as a catalyst. So all three require catalysts. So D is the correct answer. How many of the following statements about ethanol are correct? Molecular formula is C2H6. So let's figure it out. What is ethanol? It's C2H5OH. So it is going to be that, right? Manufactured from ethane and steam. That would be true, but it's not, because it's actually ethene and steam. Ethene, right? Everything else, I have a strong feeling, is correct. Oxidizes to ethanoic acid. Yes, that's true. Ethanol is oxidized to ethanoic acid produced by the fermentation of glucose. That's how you make drinking alcohol, the beverage, right? Used as a fuel. Yes, it does. Yeah, it's a good burner. They do use it as fuel. Used as a solvent. Yes, it's also a good solvent. Your perfumes probably do have some ethanol in it as a base to dissolve other scents that do not dissolve in water. So the correct answer is 5.